Biomedical Image Processing course. Today we will see the Python as an open source software along with OpenCV used for image processing, especially for biomedical image processing. Python is an interpreted language that shares many features with the C programming language and MATLAB also. These types of languages are often called scripting languages. It has common approach to quick solution to the problems and has a very large community of developers. It is under domain of open source programming languages. No variables need to be declared in this Python, and often program developed can be fast in this language. Programs are created with the text editor. The name comes from Monty Python's Flying Circus. Use of real-time computer vision is one another part of this Python, which is called OpenCV, developed by Intel, later supported by Willow Garage. The library is cross-platform and free for use under open source BSD licenses. BSD Berkeley Software Distribution License, free and open source type, may be used in commercial software also. No requirement to publish the source, must acknowledge OpenCV was used in documentation by including its copyright notices. Now see image processing and their steps how to implement in OpenCV and MATLAB. An image is nothing more than two-dimensional signal. It is defined by mathematical function f of xy, where x and y are the two coordinates horizontally and vertically located in the image. From that f of xy, we get a matrix from which we can process the gray levels. The values of f of xy at any point gives the pixel value at that point within the image. Any form of signal processing for which input is an image, the output of image processing may be either an image or set of characteristics or parameters related to the images. Now we will see various dependencies required to run OpenCV, which are mostly Python, NumPy, Matplotlib, which is optional, and so on. These few dependency we must have to have while using specially image processing in the MATLAB. Let us start with first simple most example and which is widely required is how to read the image from Python. Use the function cvt.imread to read an image from storage device. Using this function, we can retrieve the image which is present on permanent storage device. cvt2.imread color used to load a color image. Any transparency of image will be neglected. It is the default flag. cvt2.imread grayscale will load image in grayscale mode, whereas unchanged mode, if we try to utilize, it load the image such as including alpha channels also. Now here we have a small group of statement used to indicate that how we can read an image from the computer using functions present in OpenCV. Import cv2, load and color image in grayscale, where a statement is variable equal to cv2.imread in bracket in single quotation name of the file, whereas cvt2.imread underscore grayscale will be used to read the grayscale type of images. Finally, for display, a function is print in bracket name of variable in which we have stored the output of imread function. This way we can read the image. Now here it has shown the way to display the image on the display device, especially on monitor. Use the function cv2.imshow which will use to display an image in a window. cvt2.waitKey as a keyboard binding function. Its arguments is the time in millisecond. cv2.destroy all windows function simply destroy all the windows which are created. Using this function, if multiple windows are currently open, which will be get closed and buffer of the primary memory will be free for utilizing to retrieve, to execute other program or function or statement in the primary memory. Now, in this example, it has shown the output after displaying the image on the console. Import cv2, load and color image in the grayscale. For that, the function are variable img, which is user defined, equal to cv2.imread and in bracket in single quotation file name if required complete path followed by its type. Then to display the image, function is cv2.imshow in bracket the variable in which we have been read the output of imread and the type image. So it will display the image on the window. Now WaitKey is something like to have certain duration image figure window remain appear, control should be on that till the next step we will perform. Then cv2.destroy all windows will again remove the windows, close the windows, make buffer free for further processing. Using such statement, we can able to increase the efficiency of primary memory. Now let us see the process through which how we can make the image resize. It is done with the function cv2.nameWindow is the function used for resizing the images. By default, the flag is cv2.window underscore auto size. If you specify flag to be cv2.window underscore normal, you can resize the window. Import cv2 load and color image in the grayscale. So this function or a group of statement used to give the demo of how we can get the color image. So color grayscale image along with color image we can process. Now let us see how to read it. Again take a user defined variable equal to imread function to retrieve the image from storage device. Then name window function will call with image and followed by the type called normal. So it will display that in a normalized window. Then say imshow with image along with the variable in which we have stored the output of imread function. WaitKey for 0, then cv2.destroy all the windows. This way the group of statement we can execute. Now here it is going to give the flavor about how we can write the image after doing certain modification into it. Use the function cv2.imwrite to save an image. First argument is the file name. Second argument of this function is image that we are going to save, and it will save on the permanent storage device. Now here load a color image in grayscale. For that the statement required are to use IAMRead to read the image from storage device and save that into a user defined variable. Then IAMRead grayscale will be a parameter for it. Then named window with some normal parameters. Display that on the window with the help of IAMShow. Then IAMWrite function used to write the image after doing certain modification, in which fish1.png will be a name, new name. By that name we will store the updated copy of it, and followed by a variable in which currently updated image present. Then followed by wait key and destroy all the windows. So this group of statement used to give the information that how to read, show, modify and write the modified version of the image on permanent storage device. Then we will see various other transformation we can perform on the image. First one is the rotation, which is the function used for an image to rotate it by certain angle, which is achieved by transformation matrix of the particular form. Here we have a function cv2.getRotationMatrix2d from a function to rotate the image. So this will give us a matrix by how much amount of the angle we are going to rotate the image. Then we have a statement like to read the image, then image.getAShape of it, stored that into rows and column, then getRotateMatrix, stored that matrix into a variable. Their parameter are column divided by 2, row divided by 2 and 90, 1. Then we have a function called warp_affine, which will use to rotate it and without having any changes in the output version. Followed by display the rotated image in the figure window, and then the default function which we required are wait key and destroy all windows. So these group of statement used to form a matrix first for rotation, transformation, and then followed by rotated by the given set of parameters. Using this group of statement, we perform the operation on input image. Like here, an image of a fish is shown, the output after rotating that with 90-degree angle. These are the functions required to check that the feature set which I am going to retrieve from the image must be invariant. It should not change with the rotation operation. So in all angle view, it must remain constant. Now we will see the threshold, use of that threshold in Python and for how it affects on the images. If pixel value is greater than that threshold value, it is assigned one value, may be white, else it is assigned another value, it may be black. The function used is cv2.threshold, which will perform thresholding operation on the input image. Now we have some group of statements like first used to include the cv2 file in the program. For that function is import cv2. From matplotlib import pyplot as split img as a variable equal to cv2.imread to read the image. Then ret, thresh1 equal to cv2.thresholding used to get the thresholding from the image. So it will take a local thresholding, find the local thresholding of the image and retrieve that output stored into thresh1 variable, which is user defined in this particular example. Further, to extend it, the thresholding which we get will be stored into the thresh2, and in that case the certain parameter get modified. Likewise, we get trace 3, 4 as well as 5. In every case, by modifying certain parameters, we are going to get different threshold. Like in threshold 2, thresh binary is the parameter. Thresh 3, which is trunk. Thresh 4 is to 0. Whereas in next thresh called 5, which is to 0 INV. So by modifying their parameters, different threshold values we can get. From matplotlib, import pyplot as plt, then use a variable to store the output of IAMRead, then get a threshold using a function thresholding with binary as well as some binary inverse. Now here also we are going to get list of 5 different threshold by changing their parameters. In each of them we will get their respective local thresholding. Using group of bundle of threshold, we can apply it to make their partition. Now here we will assign some titles to the output of variable. So titles is equal to original image, binary, binary inverse, trunk, to 0 inverse, and so on. Then use their respective threshold, stored all of them as a list in images variable, which will be an array. Then use iterative variable I using for loop, which start from 1 to the x range. Then plt subplot going to display multiple images in one figure window. So it will divide that figure window into quadrants, and each respective quadrants it is going to display the desired images along with their specified title, so that it increases the readability for the user. Finally, all of them will be displayed using plt.show function. The output is here. The one figure window is divided into a number of quadrants, and every respective quadrants we have different types of images. This is the way to handle figure window for displaying multiple images together. Why there is need to have such a division of figure window then? Here our objective is to make comparison between original and the output generated by all successive steps. All of them, if we have displayed in one figure window, easily we can compare and understand that the effect happened by having different operations. So comparison is very easy to understand. Otherwise, each individual figure window we have to process, and it is difficult to manage for the comparison process. For that purpose, we go for subdividing the figure window into their quadrants. Now, let us see the two-dimensional convolution filter, how to process on the images in the Python. So, we have OpenCV, which will provide inbuilt set of functions for convolution, and the main function is cv2.filter2d to convolve a kernel with an image. A 5x5 averaging filter kernel can be defined as follows, where k is equal to 1/25 and in bracket all the coefficients of that filter will be 1, which is of size 5x5. Using this averaging filter, our objective is to convolve the image and get averaged image, which will be smoother image of the input. Especially such type of functions are required to remove the noise, to remove the blurriness from the image, and to make uniform distribution of grayscale. Further, to extend it, like we are going to now import numpy folder or a package as NP in this program. From matplotlib it will get import with pyplot and then use imread, store that into img function. Then we have a main important function called the kernel is equal to np.ones of size 5 by 5 and np.float of 32 divided by 25. This will use to form a kernel which we are going to use for convolution of size 5 by 5. Then cv2.filter, which is in two-dimensional, used to take an input image and the kernel for the process of convolution. It will start with topmost left corner, shifted it by one column towards the right and then followed by one row to the downwards. At the end of iteration we get whole image after a filtered operation. Then those collective set of operations along with input images at a time we can display in one single figure window with the help of subplot function. In that parameters are the size of division, then followed by index number of the image, and along with we also give their respective titles to increase the understanding or self-readability content. Like in this image we have an original image and along with the output which is generated by averaging filter. Now here we can easily compare the input and averaging. So in averaging it will take that 5 by 5 size 25 pixel, make their average and store that in output variable. This way it will process. Now image blurring means what and how it is utilized in Python and OpenCV, that we will highlight. Number one is averaging. It simply take the average of all the pixel under kernel area and replaces the central element with this average. This is done by function called cv2.blur, or we can also use cv2.boxFilter. These two main functions used for the purpose of averaging the kernel area. Check the docs for more details about such particular function, because such kernels are mostly required to get the region of interest or desired output highlighted from the input image. Now with continuation to this blurring, we have some group of steps like importing cvt2 file from matplotlib, then read the image, then do blurring with 5 by 5 size, then followed by plot the input along with outputs of their respective kernel in one figure window. So in that case, figure window again break up into their smallest size of quadrants, and each respective quadrants corresponding image along with their respective titles and so on. Like here we have original image and then the blur image, output as a blur image. Purposely the input image is demonstrated over here by blurring, and here it is smooth version of the image. Blurring can be happened if object is in steady state and acquisition device is in moving, or in a reverse case object is in moving state and due to that physical movement the blurriness can be happen in the image. Sometime it will be added due to because of the noise removal function or algorithms. Second number under blurring is Gaussian filtering. It is done with the function named as cv2.Gaussian blur. This function will blur the image according to Gaussian uniform distribution. For that we have group of statement. Start with like importing cv2 from the MATLAB, then read the image, then apply Gaussian blur on that image of size 5 by 5 filter. So it will give the output of blurring according to Gaussian uniform distribution. Then show the image original as well as blurred in the single figure window with their respective positions as well as title with the help of subplot function. This way we can manipulate it. The output of this Gaussian blur is shown over here. So we have normal blurring as well as Gaussian blurring, two major statement functions inbuilt present in Python for the purpose of blurring. The function cv2.median blur is used to apply median filtering. It used to compute median of all the pixel under the kernel, and central pixel is replaced with the median value of those group of set. This way it will process. Now let us see the group of function and the statement need to perform median filter, in which we begins with image read, then form a median kernel with cv2.median blur of size 5 by 5. So it will form a kernel named as median and which will further use for convolution. Now do the median blur with median blur method, and then finally display the images with original and output of Gaussian blur on the single figure window with respect to their index number along with titles. Like here it has shown the original image and then the median filtered output image. Okay, so this way our objective is to get the image and do on processing with the help of the median filtering. Now next main function is bilateral filtering. In that we have a method named as bilateral filter, which is present in OpenCV function library, used to apply bilateral filtering technique. This is used for effective at noise removal with the help of preserving age information within the input image. Operation is slower as compared to other filters, but output is good. Now we have a program as a statement group of methods required to process this using a function just we have discussed in earlier slide, in which begins with read and form a kernel named as bilateral filter, then display the output in a one figure window by dividing that into their respective quadrants and the output. Like here, that figure window divided into two parts. In that, one is original with its respective title, and second one is the output of blurred image and with their title. If we compare these two, the output version seems that age information has been lost. Significant high grayscale value has been lost. Now overall, we summarize here that we have seen Python for the set of operation like blurring, transformation, convolution, display the image in the figure window, resize that figure window, and so on. Next we will cover the morphology, canny operation and histogram using this Python. Thank you.